Being pasteurized, we consider it raw milk, and we take care not to mix the raw milk with the pasteurized milk. So one of the things that we can do is we can separate the cream from the skim milk, and that's using this piece of equipment. This is a cream separator. It's a fairly old style one, and so this uses a centrifuge to make the cream separation occur faster. So coming out of this, we have cream and skim milk, and so we would then blend those back. So if we wanted to make milk for the cafeteria, 1% milk, then we'd blend enough cream back in there so that it was 1% fat. For ice cream mix, we would bring them over into one of these tanks here. So we put whole milk in here. We'd add the skim milk powder, sugar, corn syrup solids, extra cream, and we'd add the stabilizer emulsifier mix, and we'd also add the cocoa powder if we're making chocolate ice cream. So from this point, it then comes to the pasteurizer, which includes this piece of equipment, and the control panel and kind of the homogenizer is part of it as well. So the purpose for pasteurization for ice cream mix, we need to heat it a minimum of 180 degrees Fahrenheit for 15 seconds. And that will kill all of the vegetative bacteria, and especially the ones that cause disease. It works in the sense that this part of the system is a heat exchanger. So it consists of a number of metal plates that are packed tightly together with a thin channel in between them. So we can run something hot up one side and something cold down the other side, and we'll transfer heat from the hot to the cold side. This allows us to heat the milk very quickly, and it's also very efficient because we can use the hot milk to preheat the cold milk. You know, so normally if you are heating, say, some milk in a pot on a stove, all of the heat either gets lost into the atmosphere and some goes into the milk, but you have no way to get that heat back. And if you want it cooler, you've got to put it in something cold. So in this one, we can regenerate the heat by taking the very hot milk and preheating the cold milk, so we transfer the heat from the hot milk into the cold milk. So it becomes a very efficient way to do it, and we can regenerate in this system about 90 to 95% of the heat. So the total amount of heat to heat it up to that temperature, we only have to provide the 5 or 10%, which we do providing steam from the system. Now, we have a control system that controls how much it's heating, and then at the back here you'll see there's a big pipe that snakes its way through here in an S shape. It takes 15 seconds for the milk to pass from the bottom of this tube to the top of the tube. When we have an inspector that comes, and part of his inspection is actually to time it to see how long it takes for something to pass through here. So we know that the milk coming out of this tube has been at whatever temperature it has, and a bit higher for at least 15 seconds. So there's that time, 15 seconds. We measure the temperature right here. And the control panel says, okay, it's 180 degrees, therefore it's being held at that temperature for that minimum time. It can then go through the system and be cooled down. If it's below 150, it automatically activates these valves, sends the milk back here to the beginning, and it has to go through again. And so we operate the system a little bit above that, so as we get natural fluctuations in the temperature control, it doesn't drop below 180. But this is the fail-safe mechanism to say, yes, every particle of this ice cream mix has been pasteurized, so there's no possibility for any disease-causing bacteria to be in the pasteurized milk. Then it's cooled down. Actually, the next stage is the homogenizer.